Compound inequalities means that the range of values needs to be restricted by more than just one inequality. I want everything that's greater than -2, but then also less than 3. So how about I write that like this? Covering it up with my hand, I can see that x is greater than -2. That's an inequality. Then cover up the other side. Then x is less than 3. Those are two separate inequalities. But you kind of have to have them both at the same time. And you know what? It's going to equal 3 as well. Just to splice it up. I think it'll actually be better if I use two separate number lines. But here, the number lines need to match up because I kind of want to look at both of them at the same time. So if that's -2, that's -2, that's 0, 0, and then this is 3. So I'm just kind of splitting up this compound inequality. So we want everything that's strictly greater than -2. So we do an open circle, go greater than 2. Cool. Then on this one, we do the other one. What we're looking at in the end to find the total solution set of this compound inequality is to see where the overlap is between both of them. Here's -2, then there's 3. We're looking for where it's true in both of them at the same time. In total, we would have this at -2, then 1, 2, -1, 0, 1, 2, 3. That's definitely a 0, not a 6. And then that's a filled in 3. Everything in between -2 and 3 and including 3. That's this. You don't have to do this if you think you got it. This is called the intersection of multiple inequalities. Intersection meaning it's intersecting both of them. It's both of them at the same time. It's intersecting. Then there's kind of the awkward, obvious intersection of a compound inequality. And it's awkward because it'll be something like x is greater than or equal to 3, and x is also greater than or equal to 5. Here's 3. And then here we're looking for the overlap between this one here and this one here. And as you can see, it's simply just this here. So that's why it's kind of awkward, because you can just say, oh, everything that's greater than or equal to 5 is also greater than 3. So you just kind of look at this one here. You're not going to see this one too much. You're going to see these intersections a lot more. And then one more thing is the union of multiple inequalities. And a union is or, meaning it's greater than x, or you'll either see the or the union symbol or the intersection symbols with like solution set brackets and whatnot. I don't want to get into that. Or should I? I think I'm going to. X is less than or equal to -3. So here in the number line, I'm actually going to put it on the same number line because they're not going to have an intersection. They're not going to overlap. -3. So there's no overlap here. There's clearly no intersection. There's no number that's greater than 5 and also less than -3 at the same time. This works for an or, though. I'm looking for any number that is over here or over here. Any of those points work just fine. Then the awkward... No, I promised I was going to do it with symbols, with solution sets. So if you see the curly brackets, we're talking about solution sets. We're talking about answers that, kind of have more than one answer. We're talking about a range of values. The curly brackets, it'll be interval notation. This is a lot of notation stuff. We have to start at the lower end first to kind of like work our way up. So everything from negative infinity all the way up to -3 and including -3. I know this looks like a coordinate point, and it kind of does. It's really confusing that they kind of use the same notation for coordinate points and for solution sets. But this is called interval notation. It's showing us that everything from negative infinity all the way up to, and that's what the square bracket is. The square bracket means that we're including. I'm actually gonna this square bracket here means that we're including. Obviously, we can't do square bracket for negative infinity because infinity is not a number, so you can't ever equal it. More on that when we talk about calculus. And then we would union, so like a big capital U, and then we're not including, so we have to do another brackets. We're not including 5, that's why I'm doing rounded brackets. 5 up to infinity. And then, of course, not including infinity. Close the curly brackets. Yeah, this is a way that you might learn how to do solution sets for compound inequalities like this, or even just a regular inequality. I'll do one for the intersection as well. I'll do this one here. This one's actually a little easier because you only need one. This is going to be the solution set of, we're not including -2, all the way up to and including 3. And that's the solution set. Curly brackets means these are all of the possible answers, for x. These are all the possible values that for x that satisfies this compound inequality. Oh my god, I'm losing my mind. Not really, I'm having a blast. It's just... So what if I wanted x equal to 3 or to 5? Compound inequality for a union or is union and is intersection. I don't know if that's a great thing to think of. And means intersection, meaning we need both at the same time, definitely. And then or means it doesn't matter, it's just got to be in one of them. I'm actually going to color these in. Why not? Here's the 3. And going this way. And we're still going less than, so this way. Now, just like this one here, it didn't matter which side it was in, as long as it is on a squiggly or a filled in circle, then it's part of the solution set. So this part counts as well. This one, we had to kind of break it off because it needs to be on both of them at the same time. This one, it doesn't matter. So this one counts as well. So actually the solution set is everything that is on any of the squigglies. It could be both. That's fine. 0 is less than or equal to 3, and it's also less than or equal to 5, but it's on at least one of them, which is what we're looking at. We'll be working with inequalities about as much as equalities, just being familiar with the couple different extra things. So multiplying or dividing by a negative number when you're doing algebra, make sure you flip the sign, and then kind of understanding that it's a range of values and there could be multiples.